So as we step away from the original 802.11 WEP security, we have these improvements. First is the 802.1x port-based authentication technology that we add to dynamic WEP, which uses a key rotation mechanism. Again, this still has many flaws and vulnerabilities, but if this is the best your system can do, you should implement this. This will keep the casual browser from stealing your signal. It will not by any means stop a guy who is sophisticated and determined. He will get into your wireless network, no worries. The next one over is the Wi-Fi Protected Access, or WPA. Now, WPA is typically, it's designed to be a firmware upgrade to your standard original 802.11 wireless hardware. It uses the same encryption algorithm, RC4, just like WEP does, and this is to keep the computational effort required to the same level as what the original WEP was designed to do. So the Wi-Fi Protected Access, which is part of 802.11i, is designed again for a firmware upgrade to your original old 802.11 hardware. So you would contact the manufacturer, download a firmware upgrade, perform this upgrade on all access points and all clients. This introduces the 802.1x port-based authentication, can use a pre-shared key, which is like a password, can implement many forms of authentication using the Extensible Authentication Protocol, or EAP, and it can also be weakened to the point where we simply authenticate with passwords. It uses an encryption algorithm called TKIP, Temporal Key Integrity Protocol, again based on the RC4 algorithm, but this solves all the problems of key rotation. The problem with WEP was everyone in the cell had the same key for authentication and for encryption. This solves all those problems. It also then uses, instead of the CRC32 hashing function, which is very linear and is closely related to the actual data, it uses an integrity validation check called MICL, or MIC, Message Integrity Code. So again, Wi-Fi Protected Access, the low end, solves all the security problems with WEP and is considered an acceptable and appropriate step forward if you have 802.11 gear. Now, Wi-Fi Protected Access, WPA, at some point, and that date hasn't been specified, will be obsoleted, and everyone will need to shift to the WPA2, which is also called the RSN, or Robust Security Network. This is the 802.11i specification in its full glory. We will all need to rotate to this particular standard at some point in time. RSN includes the 802.1x port-based authentication system with pre-shared keys, a password. It uses all the authentication mechanisms that we have with the Extensible Authentication Protocol and can even dumb down to the use of passwords. Here's where it gets heavy. It uses the Advanced Encryption Standard based on the Reindahl algorithm. Now, this encryption algorithm is so strong, so computationally demanding, the 802.11 gear, the old original gear, didn't have the horsepower to run this encryption and decryption in a sufficient amount of time. So this is where you're going to need to replace all of your old gear with new gear so that it has the extra CPU horsepower to run the AES encryption standard. It also then adds to that CCMP, which is CBC MAC for integrity validation, and counter mode protocol for a very sophisticated sequence numbering to make it very difficult for a bad guy to hijack a session. So RSN, which is the equivalent to WPA2, is the high end of 802.11i. It's eventually where we all need to be with wireless security. So 802.1x, port-based authentication. Basically, this allows the client, and in 802.1x specifications, the client is called the supplicant. This is the wireless client that wants to connect to a wireless access point and access the network behind the wireless access point. So the supplicant contacts the access point and requests an association. The access point uses this 802.1x port-based authentication to connect the client only for authentication purposes to the authentication system and does not allow the client to connect to any other services on the wired network other than authentication. So this is where this port-based authentication comes in. In other words, I'll allow the supplicant to communicate with the wired network only for authentication purposes, passing through a Radius server that may have its own user database or may contact some other directory service, such as Active Directory for user-based authentication. And only when the Radius server approves the supplicant's connection to the LAN will the access point allow the supplicant to forward packets to any other client or network node other than the authentication system. So with 802.1x port-based authentication, again, the supplicant makes the request to make a connection through the wireless access point. The wireless access point is called the authenticator. The authenticator contacts the Radius server in the background. It's a separate device, and the Radius server submits to the supplicant a digital certificate to authenticate the proper network to the supplicant. In other words, the network is authenticating to the supplicant to prove to the supplicant that he's actually connecting to the right wireless network. This helps to avoid a bogus access point that a bad guy might put up trying to steal usernames and passwords and other information, a man-in-the-middle attack in essence. So again, the Radius server sends the supplicant a digital certificate. The supplicant then uses that digital certificate to build an SSL tunnel for the purposes of authentication. Once the SSL tunnel is established between the supplicant through the access point to the Radius server and the supplicant now begin to negotiate which authentication protocol is common between the two. And they will start with typically the strongest authentication protocol first. The Radius server will ask the supplicant, can you authenticate on this? The supplicant says no. Can you do this? Supplicant says no. Can you do this? Supplicant says yes. This is now the authentication protocol that the two of these will use during this authentication process. The authentication process will continue to the point where the supplicant provides the appropriate credentials, the Radius server validates those credentials, and then approves through the access point the supplicant's connection to the wired network. Another aspect of this is the Radius server can impose many different controls over the nature of the supplicant's use of the wired network. The Radius server can mandate that if the supplicant does not use a proper strength VPN when communicating with the wired network, to disconnect the supplicant. If the supplicant is on the wireless network for too long, disconnect. If the supplicant is using the wrong protocols of any kind, disconnect the supplicant. If the supplicant tries to go to the wrong section of the wired network, disconnect the supplicant. So there are many controls through the Radius system. So 802.1x is not unique to wireless networks. It has just found a very comfortable home in the wireless arena, a very much needed location and utilization in the wireless network. So we see 802.1x port-based authentication used on wireless, token ring, and Ethernet, as well as any other form of networking communications. The authentication mechanisms that we see here are EAP with Cisco Wireless. Now this is called Lightweight Extensible Authentication Protocol. That's LEAP for the acronym. And this requires a Cisco agent on all supplicants, and it requires a Cisco wireless access point. So it's Cisco proprietary. LEAP is a Cisco proprietary authentication mechanism. We have EAP TLS. TLS is transport layer security. This is probably the strongest security at this point in time. This requires digital certificates not just on the network side, on the Radius server side, but also requires digital certificates on the supplicant side. In other words, 100% of your clients connecting to the wireless network would require a digital certificate. This introduces a huge amount of administrative overhead. The next one we see in the diagram is protected EAP. Protected EAP is an authentication mechanism that requires digital certificate on the server side to build the SSL tunnel. This secures the authentication process, but then we can negotiate everything from digital certificate on the client side all the way down to Microsoft's Challenge Handshake Authentication Protocol, a password-based technology for authentication on the client side. This is very convenient and also very secure. we can now implement with a minimum of administrative overhead protected EAP, digital cert on the server side to validate that the client is connected to the right network. This digital cert also is used in building the SSL tunnel between client and server for authentication processes. And then the client can simply use his MS-CHAP or MS-CHAP version 2 authentication protocol, a password-based authentication protocol. Very easy to implement, very easy for users to utilize as well. And the magic of the extensible authentication protocol is it is extensible. In other words, we can add any new authentication mechanisms and technologies that are developed in the future to the EAP list of usable authentication protocols.